Hi, I'm Shaun, and in Mr. Solar's class, we were learning about how stars work. So what I'm going to tell you today about stars is the distance, the temperature, and the size. So what factors contribute to a star's brightness? Let's find out. So, a star's brightness is determined by its distance. Like, Mr. Solar's grabbed a flashlight and a cup and shined the flashlight in the cup. And so the cup looked like a sun. He put it really close to our face and then walked away. When it was close to our face, it looked bright and big. But when he got farther, it became lighter and not as bright, and it looked much different than it had looked when it was near us. And the brightness is determined by its temperature. This is a really interesting picture. If you see right here, you can see the blue gets hotter, not like a sink. In a sink, you turn the handle of the red to make it hot water, and you turn the handle of blue to make it cold water. But it's the exact opposite. The red means it's not as hot as the blue, but it's still really hot if it's red. So now, I don't know. Do you ever have like a stove, or have you seen fire really hot that's like blue? Well, here is examples for stars right here, and this like kind of almost looks like a timeline in a way. So right here are these. You can see these like red and yellow. They are 3,000 degrees Fahrenheit. They're like still really hot, and like you might see that right there is the sun, and the sun looks really, really tiny than it does to up here. But I thought the sun had been like the biggest star, because the sun is giving us all the light. It's the sun, or what we might call soul. But that's not true. Just because the sun is doing all is the main source. Someone like Beetlejuice might be way bigger, and he is. Here he is, right here, really much bigger than the sun. He seems like to be one of the biggest of them all. But even the tiniest one, Sirius B, can be so hot even though it's small. But it might just look small because it's far away. The further the star is, the less bright it looks, and it looks more far away.
You're not supposed to do movie. You're supposed to do screen.
I saw a good picture, and it showed Ryan. I don't know if you know like your constellations, but Ryan's a constellation, and it showed four main stars like this, like a square kind of. So there was a star right here, a star right there, a star right there, and a star right there. So, and then there was a bunch of other stars, one forming his belt and everything. But these stars were way, way, way bright and huge. But then there were a bunch of little dots everywhere around, like everywhere else was dots. There were dots everywhere. And those dots were still stars. Some might be Milky Ways or planets. We don't know, but we can find out. But anyway, those were still stars. They were just really far away. So just because they look much different than the others, they're still really far away. The star's brightness is determined by its size. That might be a little strange, but it actually makes sense once I explain it. You can see that if you have a little yellow sticker in a big yellow bowl, if you put the yellow sticker right up to your eye, it's really, really big. And when you put the bowl further away, it looks like the sticker could even be bigger because it's closer to you. But if you put the bowl and the sticker right next to each other, the bowl's way bigger. So it all determines on the brightness, because the bowl wasn't as bright maybe as the star. Just like when I said Mr. Solar signed that flashlight into the cup, when he got further away, it looked lighter and harder to see. But when it was closer, it looked easier to see. So, now we know that the star's brightness is determined by its size. Here is bluish so here like star's temperature, like just a little chart to give you a basic idea. Reddish is 2,000 to 3,950 that's the temperature, and it's super hot, so hot. So it becomes hotter with 3,900 to 5,250. Then it does 5,250 to 5,950, and it keeps going until it gets to above 31,000. Not 3,100, 31,000. It's really hot, and that is bluish, just like we said in the chart. So bluish is the hot, right here. You can see. Now I'm going to answer a question. You can see it right here. I'll read it first, then answer it. LeBron and Tina are talking about our sun and other stars. Trina argues that the sun is much larger than all the other stars in the sky. She also explains that most of the other stars are about the same size as each other and the same distance. So Trina thinks that the sun is much larger than any other star in the sky, and she also thinks that other stars are the same size as each other and the same distance from Earth. But LeBron disagrees. He explains that the sun looks larger than other stars because it is closer. He also argues that the other stars are a great deal of in size and distance from the Earth. Who is correct? Explain your answer. I think LeBron is right, and actually I know LeBron is right.
Moving it.
As we know, I said that when something's near, it's brighter, and when it's far, it's not as bright. Right here. I'm glad this is right next to the question because you can really see this. And if Tina argues that the sun is if she explains that all stars are the same size, that wouldn't make any sense because that would mean like one star isn't bright as the other, but really that star's just far away, much farther than us, and it can't be true if they were all on one angle. So she also argues the sun is the largest in the sky. That isn't true. The sun may look and appear from our own eyes, if you ever watch the sun set, the biggest star out of them all. But that's just what we see. There are stars so much bigger than the sun, because there are stars much farther away than the sun, but still bigger. LeBron was right. He said that the sun looked larger than the other stars because it was closer, like I just said. He also argues that the other stars are a great deal in size and distance from Earth. It all makes sense. So LeBron is correct, and I just explained my answer. Thank you for watching. I hope you enjoyed. Bye.